Hello everyone, my name is Kunj Bihari Nagar. Today we will discuss about the topic two block problems, which comes under the topic of friction. Okay, two block problems means there is a one block which kept on the surface and there is another block which also kept on the first block. Okay, so how to deal with these problems? Today we will learn about this. Okay, so what are the prerequisites of this topic? There are two topics which should be learned before this. Okay, the first one is Newton's laws of motion and the second one is basics of friction. Okay, basics of friction. Let's take a quick recap about these topics. Friction is of two types. Okay, there are two types of friction. First one is called static friction and the second one is kinetic friction. Static friction and the second one is kinetic friction. What is static friction? See, friction is a very intelligent force. Okay, it changes its magnitude as well as its direction according to its motive. What is the motive of friction? The motive of the friction is to keep two surfaces together always. Friction resists the relative motion between the two surfaces. So what is the motive of the friction? Motive. Friction never forget its motive. It's not like you who always forget their motives. Whenever you are in coaching, the motive is very clear. But whenever you go to home and with your friends, you forget about it. Friction is not like that. Okay, friction always remember its motive. What is it? To keep two surfaces, to keep both the surfaces together. Okay, or we can also say that friction resists relative motion between surfaces. Okay, friction always resists relative motion between surfaces. Okay, so if friction is succeed in its motive, the both the surfaces are together, then the friction acting between the surfaces is called static friction. Okay, the first, if there is a block on the ground and we push it towards the right side, okay, and block is not moving yet. Okay, so whenever we push any block on the surface, the block doesn't move instantly. Okay, we have to push it more, then the block started moving on the surface. Okay, so the block is not moving yet, so the friction acting between the surfaces is called static friction. Okay, it's called static friction. So what is the direction of the static friction here? The direction of the static friction will in the opposite direction of the external force. Okay, so in this direction, in the left direction. Okay, and what is the kinetic friction? If two surfaces are moving, okay, there is a relative motion between both the surfaces, but friction also acting, friction also trying to keep both the surfaces together, right? So at that time, the friction acting between the surfaces is called kinetic friction. Okay, if the block is moving on the, here block is at rest, okay, it is at rest, but we are trying to push it in the right side. Okay, but in the kinetic friction, block is moving on the surface, the block is moving on the surface with any speed v. So we are pushing it, but friction is trying to keep both the surfaces together. Okay, friction is trying to stop it. So this friction is called static friction and this friction is called kinetic friction. Okay, understand that? So we have to clear understanding about this before get into the topic two block problems. Okay, now let's discuss about the our main topic two block problems. So there is a block which is kept on the ground of mass m1, and there is another block which is kept on the first block having mass m2. Okay, if I ask you that if there is no friction, not between the ground and m1 block and not between the m1 and m2 block, both these surfaces are smooth, both these surfaces are frictionless. If this is the case, if I ask you students that if I push the upper block in the right side, which block will move? The block M2 will move definitely. There is no doubt about it. What about M1? Will it move or not? If I ask you. So, what did we learn in the first law of motion, Newton's first law of motion, that any object, any body which is at rest remains at rest until and unless an external force is acting on it. So, if we talk about the block M1, there is no external force on M1. We are applying external force on the block M2. So the block M2 will move. Why should M1 move? So M1 will not move because there is no external force on the M1 block. Both the surfaces are smooth. So there is no possibility of the friction. And we are not pushing the M1 block. So block M1 will not move. Okay. Yes, sir, we are understood this. Okay, okay. Now change the scenario. Now change the scenario. In this situation, the ground, the surface between ground and M1 is smooth, but the surface between M1 and M2 is not smooth. Okay, it having some friction coefficient. Let's take it mu. Okay, there is a friction between M1 and M2 block. Now, push, if I push the M1 block in the right side, will M1 block will move definitely because we are applying force on the M1 block. Tell me about M2 block. Will it move or not? Will it move or not? Because we are not applying any force directly on M2. Okay. The only force can act on the M2 block is the friction between M1 and M2. Okay. So if we draw free body diagram of M2 block, the block M2, there is a friction between M1 and M2 is acting between both the surfaces, right? Now see, there are two possibilities. M1 and M2, if we push M1 block, there are two possibilities. M1 and M2 can also move together and can also move separately. So how can this possible? See, we have seen it in our daily life also. You have seen one example, very famous example. There is, you have seen it in videos also. If we take a paper and put a water bottle on it, okay, my bottle is not very perfect, I'm sorry about this. Okay, if I pull the paper, what is it? It is a paper. Okay, if I pull the paper very fast, the bottle will not move. Okay, the bottle will not move with the paper. Okay, the paper it came out and block will stay on its initial position. But if I pull the paper very slowly, bottle will also move with the paper. So there are two possibilities. The bottle can move with the paper also, and the bottle can stay over there, but paper will move. It means both the paper and bottle will move separately. Okay, there are two possibilities over here. So we have to, they are same as the bottle and paper case. there are two possibilities in two block systems also. They can move together and they can move separately also. Okay. Okay. See, if we draw free body diagram of block M2, there is only one force which is acting on the block M2. What is that force? It is a frictional force. Okay, it is a frictional force. What is the direction of friction force on the M2 block? It is very clear. Okay, the block M1 is going in the right direction. So definitely, if friction is trying to keep both the surfaces together, it should be in the right direction. Okay, I'm sorry, in the right direction, students, in the right direction. Okay, so there is only one force is acting on the M2 block. What is it? It is a frictional force. Okay, and what about M1 block? Let's draw a free body diagram of M1 block. Okay, block M1. There is an external force also acting on the block M1. This one. And friction is also acting on the block in the opposite direction of M2. Okay, so friction. So there are two forces are acting on the M1 block. But if we discuss about the M1 M2 block, there is only one force. Okay, it is friction. So only friction is a only सब सही है? Only friction is responsible for the moving of M2 block. Okay, so what if we write the acceleration of M2 block, what will it? What is it? It is F by M2. Okay, so see students, we can increase the acceleration of M1 block as much as we want because the external force is in our hand. If we increase F1 force, sorry, external force, the acceleration of M1 block will also increase. But, 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 if we talk about M2 block, there is a maximum limit of frictional force, and the acceleration of M2 block cannot increase cannot increase after the limiting friction. Okay, the force on the M2 block cannot increase after the limiting friction. Okay, so there is a limit of the acceleration of M2 block. So both the friction will try as much as he can to keep both the blocks together. But if it failed, then both the block will move separately. Okay, so there are two cases. So how to deal with this? How to deal with these type of questions? So there are few steps we should be follow, and we can solve with these steps. Okay, so step number one, I'm gonna rub that part so we can understand it more better. So I'm rubbing it. See, okay, so there are few steps. Okay, so step number one, what is step one? Consider both the blocks are moving together. Okay, consider both the blocks are moving together. Okay, okay, and find the acceleration of the combined system. Okay, so let's find the acceleration of the combined system, the block M1, the block M2. Okay, so we will, these are moving together. Okay, so these are not two body anymore, these are a single body now. Okay, so these both are a single body now. And what is the mass of that single body? It is m1 plus m2, sir. And what is the net force acting on the combined system? It is F, external force which are we applying on it. So what is the acceleration of the combined system or combination? It will be F by m1 plus m2. Okay, but we are not sure that will both block move together or not. So we have to cross check it. Okay, so we have to cross check it. How shall, sir, how can we cross check it? How can we cross check it? So let's draw free body diagram of any one of two. Okay, so let's draw a free body diagram of m2 block. Okay, fbd of m2. So if we draw free body diagram of m2, the block m2 is moving with acceleration of combined system, and the force acting is friction force. I'm calling it friction required. Why? Because it is a required friction to move both the blocks together. Okay, so we can find required friction to move both the blocks together. Okay, with the help of the free body diagram of m2. So F required is F is equal to ma, the second law of motion. F is equal to ma, m2 into a, acceleration combined system, acceleration of combination, because both blocks are moving together, right? Combined. So it is a required friction, students. It is a required friction. If limiting friction, if limiting friction if required friction is less than limiting friction, if required friction which is required to move both the blocks is less than limiting friction, the friction is sufficient to move both the blocks and both the blocks will move together, right? So I'm rubbing this part also. I hope you have noted it. Okay, actually, okay, see, what is the second step? We have found the required friction. Okay, so it is a required friction. Step 2, calculate calculate limiting friction. Calculate limiting friction. What is limiting friction? It is mu s n. Okay, it is a limiting friction. That means it is the maximum magnitude, it is the maximum value of friction which can act between the surfaces. Okay, so if this limiting friction is sufficient to move both the blocks, both the blocks will move together. So there are two cases over here. Okay, the case 1 and the case 2. The first case is if required friction is less than limiting friction. If required friction is less than limiting friction, that means friction is sufficient to move both the blocks together. It is succeed in its motive. Okay. So the first conclusion is that both the blocks will move together. Okay. The second conclusion is the acceleration of both the blocks is a combined. Acceleration of both the blocks is a combination or a combined. Third, the friction acting between the surfaces is F required. Friction. These are the three things we have to find in the two block problems which have been asked in the exams. Okay, and it is a very famous question. Okay, for JEE it is a moderate level question, but for NEET it is a little bit upper moderate. Friction acting between surfaces is F required. Is F required? Okay. Now, what is the second case? The second case is if required friction is greater than limiting friction, then friction is not sufficient to move both the blocks together. And now both the blocks will move separately with different accelerations. With different accelerations. So there is a very less space over here. So I hope you can see clearly. The first conclusion is that both the blocks will move separately. Okay, so I'm writing it in short. Move separately. Okay, move separately. The second conclusion, the acceleration of both the blocks. So we can find their accelerations through their free body diagrams. So the free body diagrams of M2 block is like this, the M2 block. And what is the force acting on M2 block? It is kinetic friction. Okay, it is kinetic friction. Okay, and acceleration of M2 block is Fk kinetic friction by M2. Okay, and what is the value of kinetic friction? It is mu k n. Okay, so there is a very less space, so I'm not writing it right now. And what is the acceleration of second block? We can draw free body diagram of second block. The external force is acting on the first block. It is the second block, and kinetic friction is also acting on the first block. So what is the acceleration of it? F minus Fk. Sorry. Fk. F minus Fk and upon M1. Okay. This is it. And what is the third conclusion? Third conclusion is friction acting between the surfaces is kinetic friction. Friction acting between surfaces is Fk kinetic friction. Okay, that's it. That's the complete process of dealing these kind of problems. Okay. So there are three things which have been asked in the exams. What is the friction acting between the blocks, and what are the acceleration of both the blocks? So we can deal this type of question like this. Okay, so follow these steps and you will get your answer. Thank you, students. I hope you will understand the lecture. Thank you.